demonstration video on test-driven development. Before I do the actual code bits, I just want to talk a little bit about TDD and why we do it. So there are lots of great benefits to test-driven development, including, but not limited to, it provides us the shortest feedback cycle possible. So it tells us whether or not we're building what we intended to build very quickly. It ultimately leads to a reduced cost of change because when we change things, the tests inform us that we're changing things, and it represents in broken tests, right? And so broken tests are okay in the sense that they tell us, hey, you changed something and you broke some tests, but they lead us to you broke the tests you expected to break, as opposed to breaking something else. Ultimately, this helps us get to a faster time to delivery, and it allows us to make changes with confidence and courage because we have a test suite that's going to tell us if we broke something we didn't expect to break. We also get, as a side effect, regression tests and test automation. So we don't have to do a second activity of creating unit tests after the fact. The process of test-driven development leads to that as a side effect. The tests themselves, when well written, become living documentation for how the system is expected to behave. And it enables us to do safe refactoring. So as we're changing the design of code, the tests tell us if the refactoring we just did broke a behavior. We also end up with clean and lean code. We only write the code we need in order to satisfy the tests we've identified, and it gives us an opportunity to clean that code and make sure that it meets our internal standards for code quality. So that's why we're doing it, right? But what is TDD? TDD is really a interactive design and development practice. So it's not actually about the tests, it's about very, very small incremental steps towards evolving to the best possible design, and it has the happy consequence of having created tests. So how do you do it, right? Well, there are 3 laws of TDD. First, you must write a failing test before you write any production code at all. You must not write more of a test than is sufficient to fail or fail to compile. So you write the smallest possible test, right? And then you must not write more production code than is sufficient to make the currently failing test pass. So by following these laws of TDD, it makes all of our steps very, very, very small. Tests are tiny, the amount of change we're making is tiny, and there are some big advantages to this. One, we're thinking in small increments. We're breaking down the problem to tiny bits. When we make a change, if it doesn't do what we expected or it doesn't work, right, we can't get the test to pass, we've only written a tiny little bit of code, so it should be easy to fix. So one of the things we want to be sensitive to is if I'm writing a lot of code, either a lot of test code or a lot of production code to pass a test, I could probably be taking smaller steps. And that's one of the challenges of developing the skill set around TDD, is finding those ways to create tiny little forward steps. So if we use these 3 rules, or laws of TDD, to understand how we're building code, we're going to make tiny little progressive steps forward. And what the result of this is really tight, clean, lean code that satisfies our objectives. So within doing the work, right, there's what we call the Nano-Cycle of TDD, red, green, refactor. And this is just a simple way to help ourselves remember how do we do this. So we start with a failing test, narrowly defined. We write just enough code to make that pass without breaking any other tests, and then we clean up after ourselves. So we tweak the design, modify the implementation to make it as clean as possible. All right. So what I'm going to do is I'm going to demonstrate using Python for a AWS Lambda that plays a game called FizzBuzz. You may have heard of this game. The idea is that any number divisible by by 3 is fizz, and any number divisible by 5 is buzz, and any number divisible by both 3 and 5 is FizzBuzz, and all other numbers are just themselves. So the normal problem statement is write a program that generates a list from 1 to 100 using the FizzBuzz rules. So the list would come out as 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, FizzBuzz. Right? So we would go through that progression all the way up to 100. So we're going to test drive those rules. We're not going to put the loop around it, but we're going to pretend like there's a lambda in the world, that when we pass it a given number, it will return the appropriate response. And so the external program could be, hey, for any given number, is this FizzBuzz, or the number itself? So I'm just going to walk progressively through the steps of code. I've already written all this code, so you don't have to watch me type. So we start out with an individual test, right? Because we write the test before we write the code. Test that the Lambda function FizzBuzz returns 1 given 1. So we expect to see 1 here. We are giving it an event. So lambdas accept events. They're structured like dictionaries. So the event contains given 1. And we have a context of none because we don't really care about the context, but it's required to satisfy the Lambda function interface. So the Lambda function will return an actual value given that event, and we want to assert that the actual is equal to the expected. So in the process of developing this test, and any test, the way that I typically work at this is I say, well, what am I trying to prove? What is the assertion, right? And sometimes I write that out in very, very gory detail. I would make an assertion that says, I expect to receive 1 as a string from a Lambda function given an event that contains a dictionary with a key given and a value of 1. Right? So that's my expectation. And then I clean that code up, if you will, and say, okay, here's my assertion. Then what would I have to do to get my assertion? Or the values for my assertion. So what is the action? And then what did I need to do to set that up? So I kind of work bottom up. And this is just my technique. You can get here however you get here. But the things that you're keeping in mind are arrange. What do I need to do as setup? Act. Take the action. And then make an assertion, or AAA. Another way to remember that, if you don't like AAA, is C, like the ocean. Setup, execute, and assert. Okay? So, here's our first test. It does not compile. Compile is funny in Python. It does not interpret correctly because Lambda function doesn't exist. So if I were to run the test suite like this, I will see failure, and I can look at the failure, and it says name error, Lambda function is not defined. So the next thing I would do is the tiniest amount of work to make that test stop complaining about that problem, right? So that tiny step would be add a function named Lambda function that I can call. Now in real life, I would probably put this Lambda function in a separate file because I don't need to deploy my tests when I go up to AWS. But to keep things simple so there's not too much screen kung fu going on, I'm keeping it right here in front of us and just saying, hey, look, here's a Lambda function. And now that little red line under Lambda function is gone, but it is complaining, well, Lambda function doesn't return anything. So if I run the tests again, I will see now I'm failing because none is not equal to 1. Python functions return none if they aren't instructed to return something else. So none isn't equal to 1. The next logical step, the smallest possible step, is to say, well, let's have that return 1. No elegance here, no logic, no smartness, just return what I need to pass the test. And so when I run the test, it passes, green check mark, yay, happy trees, right? Bob Ross. So I now return 1. I have done the simplest possible thing. I look at the code, is there any way I can clean this up or make it prettier? Any changes needed? And the answer is yes. I can shorten up the expression of my test to simply say, assert that when the Lambda function is called with a dictionary containing a key given, whose value is 1, and no context, I should get a string back with the digit 1 in it. That is as clean as I can make that code. So that's all well and fine, but that's only one small fraction of the overall problem. So how do I get code to show up in here that says, think about what event we just received? Do something meaningful. So the next possible step would be, well, what happens if I ask for 2? I'm going to run the test one more time, make sure that they're green, and then I'm going to look at the next step and see, oh, I've decided that I needed to name my arguments just to clarify, what does this mean? What is this dictionary given 1 and what is the none? I'm going to run the test again. This has no effect. Everything is green. I'm going to crawl again to the next step. I'm going to add a test, and I'm going to say, given the if given is 2, then I should get 2 back. So I run that test, and it says, oh, that fails because it's still returning 1. So 1 is not equal to 2. So then I think about, well, what is the simplest thing I could possibly do? And the simplest thing I could possibly do is say, take the given number and stringify it, right? Some might argue that there might even be another intermediate step here, but I think that this is a reasonable leap forward in, I know Python well enough, I'm a good enough programmer that I know that all I really need to do is stringify the given value. So I'm going to change this line of code to stringify the given number. And I run the tests, and yay, verily, they pass. So now we're getting to something interesting. We're getting to 3, and 3 is supposed to return fizz, not the number 3. So we already know, right, that that's not going to work, but we're going to go ahead and we're going to add that test, and it's a failing test that says, given that I provide 3, I will get fizz back, and we will run that, and we expect this to fail. And oftentimes when we're doing TDD, we expect the test we just wrote to fail. In fact, it's usually a surprise when it passes, but sometimes it happens. We don't realize that it passes, and that's okay. No harm, no foul, right? So test lambda function FizzBuzz returns fizz given 3 is failing because there's no logic up here to do anything about it. So the simplest thing we could possibly do is intercept the event before we get to line 2 and say, hey, if this thing is equal to 3, return fizz. That'll make that test pass. It's a little facetious, and we know that, right? But it is the simplest thing we could do. So we add the code that says, if event given is equal to 3, return fizz. Excellent. So now let's run our test. It passes, and we look at the code and we say, well, is there a little bit of cleanup? This is the refactor step. Is there a little bit of cleanup we could do? And we see that event given is used twice. And that's sort of wordy, right? So we can say, well, I can clean that up just a touch. And I can pull event given into a variable called given, and now my code reads a little easier. I haven't really changed any of the behavior. I haven't added any new functionality. I've just made that piece of the world cleaner in one tiny step. So this is the place where I'm looking at my coding standards and I'm thinking about clean code. I'm thinking about readability. Saying, okay, yeah, I could do this. It would make it a little more straightforward. So I run the tests again. They pass. Terrific. What's the next thing I could do? Well, there's no more cleaning I can do to the code. The code is nice and tight. The only thing I see is duplication. I see over and over and over again, assert lambda function given something, return something. This I would clean up if it were production code, but because it's my test code, I want to leave a little bit of duplication behind because I want to make it clear to the reader that these things are important relative to the test. So I call this leaving the test code moist. It's not completely dried out. Dry is the term we use for duplication reduction. Don't repeat yourself. So instead of repeating ourselves, we consolidated given into this local variable. Here we're going to leave it moist, and we're going to say, I'm going to leave all that because it explicitly tells the reader, I am asserting that the lambda function given a dictionary that contains a key given with the value 1 and no context will return the string 1. Even though the real difference between each one of these tests is simply the number given and the string returned. I'm leaving that moisture to communicate fully, right? If you think back to your English lit class, right, They talk about passive sentences, and they talk about nouns and pronouns and verbs and how you use them. And they say, well, sometimes you have to remind the reader what we're talking about within the paragraph because the paragraph is long. So don't use contractions, don't use, use proper nouns to make it clear what we're talking about. Okay? So we run this. Everybody's happy. It's green. We crawl to the next step. And we see we've added a test to check for fizz for the number 6. So why did we pick the number 6? Well, 6 is the next thing divisible by 3. And we know what our goal is. Our goal is that for all things divisible by 3, we want to return fizz. And if you think about it, what that really means is that given equal 3 only handles one case of things divisible by 3, only 3. 6 is the next thing divisible by 3, so let's try that one and see what happens. Okay? So we run this test. It fails. It says I got 6 and I expected to get fizz. What's the smallest change we could possibly make to get that test to pass without breaking any other tests? The answer would be take given modulo 3 equals 0 would work for all numbers divisible by 3, so that's the change we'll make. Okay? So you see that little change. Given modulo 3 equals 0. We run the tests. They all pass. Terrific. We're making forward progress. Now, I'm talking to you and I'm stepping through all of the explanation, but this is close to real time as fast as it works in real life. So I've taken 12 steps so far in just a few minutes, and I would continue to do this all the way through the problem, no matter how big the problem was, because I'm breaking it down into these tiny little assured steps going forward. Recognizing that FizzBuzz is kind of a trivial problem, even with big problems, this works extremely well. So, next step. Now we work on buzz. We scroll down here, I've added another test that says given 5, I should get buzz. Notice that I'm not concerned about the fact that I went 1, 2, 3, 6, 5. I was focusing on dealing with things divisible by 3. Now I'm going to focus on things divisible by 5. So given 5, I should get buzz. And I run this, and I expect this to fail. I've made no appropriate changes yet. So 5 is not equal to buzz. What's the smallest thing I could possibly do? Well, the last time I did this, if given equal 3 returns buzz fizz was the simplest thing. So I'll add if given 5 return buzz. So next step, look here, we say aha. Given that I receive 5, return buzz. Run it. Yay, it passes. Now, the next thing would be to say, okay, so for things divisible by 5, all things divisible by 5, I want buzz. I'm going to make the same change I did before. So what's the test for that? The test for that would be the next divisible by 5 number, which would be, looks like I have a step in here to fix a spelling error. Sorry. The next step would be given 10, I'm going to return buzz. So I add that test, I run it, I expect it to fail. It does. 10 is not buzz. We expected that. We're going to change this one again to given modulo 5 equals 0. And then we're going to run the test again. And it passes. Cool. We're making progress. So what's the next thing? Well, we know that we have to deal with things divisible by both 3 and 5. When the number is divisible by both 3 and 5, we want to return the string FizzBuzz. So, 18th step, we're adding a test case for FizzBuzz, and we say, hey, test the Lambda function FizzBuzz returns FizzBuzz given 15. We don't expect this to pass, we expect to get something else, and in fact, we get fizz is not equal to buzz. So how did that happen, right? Well, if we go back and we look at our code, we say if we were given 3, return fizz. So the code is short-circuiting out and saying the first thing that matches, we're going to return fizz. So how could we change this? Again, following the pattern we had before, and we do this on purpose, right? We're not trying to overthink anything, just what's the simplest thing that'll make this test pass? We say, aha, if I'm given 15, return FizzBuzz, right? Now we recognize that's sort of facetious, but it's okay, because It's one step in evolution to getting us to green. Now, what would be the next reasonable test? Well, we could say, hey, I want to find out what happens when I use 30, right? Which is the next thing that has the common denominators of 3 and 5 after 15. So I crawl forward and I see this new test. Given 30, I'm going to return FizzBuzz. I'm going to run that expecting it to fail, and it does. Fizz is not equal to FizzBuzz. It did the same thing we did last time. Given 15, I'm going to return FizzBuzz, but I wasn't given 15. I was given something divisible by 3. Therefore, I got Fizz. Cool. Same fix again. I want to do given modulo 15 equals 0 here, and that will get me to passing. So you can see the change shows up here. I run it. It passes. Okay, I have now satisfied the FizzBuzz requirements. I have test cases for things that aren't divisible by 3 or 5. I have things for divisible by 3. I have things that are divisible by 5. And I have things that are divisible by 3 and 5, showing me that I would in fact generate the entire sequence correctly. Notice that I did not exhaustively test the entire list. I thought about the numbers, and I said, these numbers are the minimum representation of the rules of FizzBuzz. I don't clean up any of the redundancy or anything like that because these things run insanely fast. If you look at these run times, they're all sub-millisecond. The entire suite runs in less than a millisecond. It's not worth my time, and in fact, if I were to eliminate too many of these, I might lose the clarity of how the system works, right? So this gives me nice clarity on how the system works. It gives me balanced test cases around the edge conditions, telling me this is what that code should do. Now, here's where it gets more interesting, right? I can now start refactoring at will and make this code cleaner. Warning, there's a thing called code golf, right? Where we essentially try to write things as tightly as possible just for giggles. That's fun, but it's not necessarily the most expressive thing, and it may lead to confusion. However, I do see a fair amount of issue with this particular function. The first one being multiple return points are kind of annoying. If this function were to get too long, it might be hard to know what it's going to return where. So right now it's relatively short. It's 8 lines of code. But if it were to get to 12 or 15 or 20, it might get harder. A lot of clean coders will tell you limit your function length to 10 or 12 lines, but that's not always possible or appropriate. So in thinking about the structure of our code, I want to reduce the number of return points, but I don't want to break anything. So what's the simplest thing I could do to get there? Right? Well, the simplest thing I could do is say, let's get a variable to capture our response, and we'll set it to blank because we don't know what the response is yet. And then we'll say, hey, if I were given something mod 3 equals 0, the response should be fizz. If I were given something mod 5, the response should be buzz. However, I may be mod 3 and 5, so I will add the two results together to get FizzBuzz. Then I will say, hey, if response has a value, I'm going to return response. But if it's still an empty string, I'm going to return the stringification of what I was given, right? So this is all well and fine. This is, cleaning up the code for minimizing duplicity, trying to make things very clear, have a single return point. It's still a little golfy, right? So it's still harder to read probably than it needs to be. In particular, line 8 is a little clumsy because it's an inline if, and I don't know, personally, I find those harder to consume, right? So I run the test, they still pass. So terrific. We did a proper refactoring, remembering that when we refactor, we are changing the internal design without changing the external behavior. And our tests have told us we did not change our external behavior. So this is a clean refactor, and that's great. But looking at it a little more closely, we could use some of our knowledge of Python to make this slightly better. And we could say, hey, what if we got rid of that if-else thing? Would this be more clear? Now, me personally, I find this very clear. Return response or a stringification of what was given. Let's see if that refactor worked. Sure enough, it still works. So this is just a quick demonstration of how test-driven development works. The entire process takes, a change in your cadence. So instead of thinking about all of the possible aspects of the code for, some long period of time and sketching out designs and things like that, we can just start with, well, what's one simple thing that should be true? In FizzBuzz, that's when I give you 1, I better get back 1. And then we work our way up progressively, elaborating out the design. So for larger problems, we would just continue this process and continue to identify opportunities to refactor this Lambda function. And if this were a real project, we would eventually take this Lambda function and move it to its own file so that it's deployable. Thank you for your time. If you have any questions, please feel free to reach out and talk to me.